Hello everyone, here is Mariam Shref, a senior petroleum engineering student at the Lebanese American University. Welcome to our last technical session at this conference titled The State of Artificial Intelligence and Machine Learning in the Petroleum Industry, presented by a distinguished expert, Dr. Shahab Mohaghegh. Dr. Shahab Mohaghegh is a pioneer in the application of artificial intelligence and machine learning in the exploration and production industry. He is a professor of petroleum and natural gas engineering at West Virginia University and the president and CEO of Intelligent Solutions, including more than 30 years of research and development in the petroleum engineering application of artificial intelligence and machine learning. He authored 3 books, Geoanalytics, Data-Driven Reservoir Modeling, and the Application of Data-Driven Analytics for the Geological Storage of CO2. And with more than 230 technical papers. And he carried out more than 60 projects for independent NOCs and IOCs. Moreover, Dr. Mohaghegh is a SPE Distinguished Lecturer 2007 and 2020, and he has been featured 4 times as the distinguished author in SPE's Journal of Petroleum Technology. In addition, he is the founder of SPE's technical section dedicated to AI and machine learning. Dr. Mohaghegh has been honored by the US Secretary of Energy for his AI-based technical contribution in the aftermath of the Deepwater Horizon incident in the Gulf of Mexico. And he was a member of the US Secretary of Energy's Technical Advisory Committee on Unconventional Resources in 2 administrations. Finally, Dr. Mohaghegh represented the United States in the International Standard Organization on Carbon Capture Storage Technical Committee, 2014 and till 2016. So please join me in welcoming Dr. Mohaghegh. So welcome, Doctor, and thank you for joining us. And we are excited to hear from you about how is AI transforming the oil and gas industry. Now, as a reminder, if you have any question related to the technical content of the presentation, please feel free to drop it down in the Q&A section, and we will try to answer as many questions as possible given the time limit. Now, without any further ado, Dr. Mohaghegh, the mic is yours.
Thank you very much. It's a pleasure to be here, and also thank you, Dr. Ahmed and Dr. Suleiman, for making this conference. As was mentioned, it's the state of artificial intelligence and machine learning in petroleum engineering. The outline, I'm going to talk a bit about, I'm going to provide definitions of AI and machine learning. The reason I'm going to do that is because, unfortunately, some definitions that recently have been published in our industry turns not to be correct. So I'm going to provide you with that definition, and definition that I show you are not the definitions that I came up with, but definitions from those people who created AI and machine learning. And then I'm going to talk about petroleum data analytics very quickly, which is the application of this technology in our industry. And then my objective is to talk about the state of this technology in our industry. Has to do with 5 different items. One has to do with the differentiation and the difference between traditional statistics, which have been around for a century, with artificial intelligence. Also, the engineering application of this technology with how does it compare to non-engineering application? Because when you deal with Google and Facebook and Netflix, all of these are a strong AI applications, but they're not engineering applications. And I try to explain that. Then I talk about how physics is modeled using AI. And then the 2 items that I hope to be able to talk about it, but given the time, I may not be. One is explainable AI. The other one is ethics, AI ethics, ethics of artificial intelligence, which both of them are very important in our industry as well. However, I'll try to take the last 10 minutes of my talk, which is I'm going to talk about 40 minutes. The last 10 minutes, I'm going to show you what we recently dealt with called Geoanalytics. We developed it, and Geoanalytics is an application of AI, or actually AI-based geological modeling. And if you are a reservoir engineer, I'm sure you'll enjoy this. So with that, let me start with the definition of artificial intelligence and machine learning. Let's start with artificial intelligence. This is a very simple and quick definition of artificial intelligence. Artificial intelligence is the technology that simulates human intelligence. How does it do that? It does that through mimicking human brain. It does that for analysis, modeling, and decision making. I'm going to go a little bit detail of that as we move forward. What is machine learning? Machine learning actually is a series of algorithms that allows artificial intelligence to be done. And the definition of machine learning is it is the science of making computers to act without being explicitly programmed. And it does that through using open computer algorithms and learning from data. And please keep in your mind that when you use numerical simulation or any other things that we've been doing somehow until now, we do actually explicitly program and tell the computer what to do. In machine learning, it's actually the opposite. It's without being explicitly programmed. For example, in numerical reservoir simulation, we write the code and we tell the computer what to do step by step to every single piece of thing that we want to be done. But in machine learning algorithm, that's not the case. It's a general computer algorithm. It's an open computer algorithm that learns from the data. So the same algorithm, which is open algorithm, you can provide completely different data, and the same algorithm would act and provide you with the results that you want. So it is not a explicit programming rather than is open computer algorithm. And of course, deep learning is an artificial neural network, which I'm going to explain what that is, learning from data and the idea is pattern recognition. So with that said, let me give you a little bit more detail. Artificial intelligence mimics nature to solve complex and dynamic problems. And as I said, it deals with human brain. It tries to simulate human brain. And human brain is constructed by evolution to deal with uncertainties and various possibilities. So in this context, there are three algorithms that I have been using a lot. That doesn't mean these are the only algorithms of machine learning that needs for AI, but that's what I have been working with for a long time. One of them is artificial neural network, which mimics the neurons in human brain. Remember, AI, we said that it mimics the human brain. However, mimicking human brain, one part of it is mimicking the neurons in human brain for the learning process, and as you can see it here. And learning through pattern recognition, it uses data and to train a series of open algorithms and literally tries to mimic these neurons that I'm going to talk about it a little more in a few minutes. However, there is another algorithm called fuzzy set theory. It also mimics human brain. However, not human brain neurons, rather human brain logic. And that comes to the fuzzy logic, fuzzy set theory is fuzzy logic that it avoids the limitation of two-valued logic. Yes, no, black, white, 0, 1, in order to expand the potential to learn and make reasonable decisions based on non-exact information. Because as human, all of us, when we make decisions or when we even have a conversation, we never use two-valued logic. We always use literally infinite value of logic, not only 0 and 1, but every number between them. And finally, the third one that we use is genetic algorithm, which mimics Darwinian evolution theory in order to optimize the process that you want. And genetic algorithm is an evolutionary computing process that finds solutions and performs optimization in order to complex problem through the natural selection that was created by Darwinian evolution theory. So with that definitions, AI and machine learning, if you, once you become very interested in this technology and keep going, after a while, you'll find out that you become incredibly interested in philosophy. And that's the first thing. And then you become very interested in neuroscience and in computer science. And of course, others, things like statistics or biology and mathematics are also important, but they're not as important or not as you will not be as interested in them as you will be on philosophy, neuroscience, and computer science. And when I say philosophy, is because solving engineering related problem, you find out that it is very, very different. Your domain expertise becomes very, very important. However, your approach to the solution is going to be very different from the way we traditionally have been doing this for a long, long time. That's what the philosophy is. I'm going to go into the detail of that a little bit. But let's talk about petroleum data analytics, what it is. It is application of AI and machine learning in petroleum engineering. And the key is it uses data as the starting point, as the foundation, as the main building block of analysis, workflow, modeling, and decision-making. And what petroleum data analytic is not, and that's one of the problems that makes the state of this technology pretty poor, actually, in our industry, is that a lot of people confuse it and they think it's the same thing as statistics, traditional statistics. Why? Because traditional statistics have been using data. The only difference is, I'm going to talk about the difference between them in a minute, but don't forget, traditional statistics was created 110 years ago from Germany. However, what we call AI and machine learning today was created in 1986, the way it is used right now. Another thing that it is not an IT-related discipline. IT is the use of computers to store and retrieve data and information. And it is something that we all, no matter what we do, we need IT. But PDA, Petroleum Data Analytics, it is not an IT approach. Another thing, and the reason I'm saying this is that you'll find out that one of the major problems that we have, a lot of people think it's statistics, a lot of people think it is IT, a lot of people think it should be combined with mathematical equation. They call it hybrid model, and that's another problem. And that's really is not. We can go into detail of that why you should do that. So PDA, Petroleum Data Analytics, completely changes the role of data in how physics is modeled. Data is not there to serve our understanding of physics, and physics completely is modeled using data. And one thing we need to know is that because the way we do it traditionally, we have an understanding of physics at any given time. And as you all are very well know, that when you do research in decades, our understanding of physics gets better and better and better. It's not never the same, right? So at any given understanding of physics that they have, we know what kind of data we need, and we'll ask for that data to be collected and brought to us. So data is there to serve our understanding of physics in traditional engineering and science. However, in AI and machine learning is exactly the opposite. Data is not there to serve our understanding of physics. Data is there for us to model the physics only from data, not from mathematical equation. And all of that said, one of the major issues that petroleum data analytics is highly inspired by physics and geology, with one major difference, and that is the physics and geology are not deterministically and rigidly formulated in PDA. The geoanalytics that I explained to you, you can actually see it there as well. So physical phenomenon that needs to be modeled, data is generated and brought into AI, and then data-driven model develops, a data-driven model is developed, and of course you have to go back and forth. This is not something you can do in one shot. It's a process that goes up and down and back and forth for a long time. So, and also one more very important thing, that petroleum data analytics uses hard data to reach its conclusion. What is hard data? Hard data is different from soft data. What is soft data? Soft data is something that we generate through mathematical equation. Hard data is what we measure from the field directly. It's the fact, it's true, it's reality. So PDA works with that. Why? Because the objective of PDA is to avoid any assumptions, any interpretation, any simplification, any preconceived notion, and any biases. It should be all about reality. It should be all about facts, nothing else. And the only people who can do it for oil and gas industry are absolutely domain experts, people who are experts in AI and machine learning, but have no idea what petroleum engineering is. They cannot do the same thing. We have a lot of examples like that in our industry, unfortunately, but still it's going on in some of the companies. Anyways, it integrates well trajectory, well log, core analysis, well test, PLT, ILT, seismic, and as you can see, all of these are measured data. So what is the current state of this technology in our industry? Unfortunately, in the past 7 years, the state of AI and machine learning in petroleum industry has been very poor. Why? Well, artificial intelligence and machine learning for the overwhelming majority of the service companies and vendors is all about marketing. It's all about business. And it has very little to do with science and technology. The objective is to make money. Why? Because this technology is very sexy right now. Everybody wants it. So as long as it doesn't matter whether I understand it or not, as long as I use the word AI and I can market it and make the business and make money, then that's all it takes. That's very unfortunate, but unfortunately, it's a lot of truth associated with this in the service companies and some of the vendors. Now, with that said, how can operating companies, their management, or everybody else, how can they realize that the realistic AI and machine learning is the state is realistic or not with these vendors? And how do you find out? Well, there are two major issues that are associated with the service companies and vendors that has this problem. First, one of them, that's one of the things I've been talking about for more than 20 years. A lot of people didn't like it, but it's very true, is because at the beginning, everybody used AI and machine learning experts from Google and other places, and they gave them millions and tens of millions of dollars and to solve problems and a lot of data, and nothing came out of it. Why? Because they were AI and machine learning experts with superficial understanding of engineering. They didn't have domain expertise. And when that happened, when they do not realize that there are major differences between engineering versus non-engineering application of AI, that's one of the major problems that they have. The results are always poor without knowing how to teach the machine learning algorithm. Keep one thing in mind. When you say machine learning, right, what learning requires? Learning requires teaching, right? For all of you that are students and get taught, and for all the professors that teach, that makes perfect sense, doesn't it? So in order to teach, the only thing is you're teaching the machine for machine to learn. With one major issue that exists, when you teach to the students, you use language, and you for petroleum engineering, let's say, or for engineering in the university, you believe that they know calculus 101 or physics 101, and then you start explaining other things to them. That is not done for machine learning. When you teach a computer, when you teach an algorithm, when you teach the machine learning, the only option you have is data, nothing else. No language, of course, unless it's Python or R or other computer language. but it's not English or Arabic or Farsi or German or Spanish. So you cannot use human language. You cannot assume that the machine knows calculus or physics, and then you have to be able to teach them. The only object that you have is data, and therefore, in order to be able to and question, can you teach reservoir engineering to anybody if you're not a reservoir engineering expert? It's obvious, right? So how can you teach something to machine learning if you're not expert in what you're trying to teach to it? And the data is the only tool that you are using to teach the domain expertise to the machine learning. So that is one of the major problems that we had originally, still happens in many of the companies. The second one is using domain experts with superficial understanding of AI and machine learning. So we go from one area to another area. Here, now, unfortunately, we have a domain experts. However, they don't understand fully what AI and machine learning is. Why? How do you know they don't understand? Well, first, when they tell you that linear regression is machine learning, when they tell you the statistics is machine learning, what does that tell you? That should tell you that they do not understand this technology. When they use hybrid model, when they combine artificial intelligence with the data that is generated from mathematics with the actual data, then bring them together, they call it hybrid model. That tells you that they do not understand AI and machine learning. When they use non-engineering application of AI and machine learning to solve engineering-related problems, such as convolutional neural network that was generated by Google for image recognition, or what LSTM that is used for natural language processing. When they use that exactly in that case, in that shape, to solve engineering-related problem, what does that tell you? That tells you they do not understand this technology. Do they have to understand convolutional neural network? Absolutely. But if you use convolutional neural network to reservoir engineering, is reservoir engineering fluid flowing porous media is convolutional? Absolutely, it's convolutional. But in order to explain it, you have to deconvolve it. You have to bring in a spatiotemporal database and make the AI algorithm to be able to separate them, the space from the time. And then when you do LSTM, they use only time, nothing about space. So we can go to a lot of detail of these, but this is just an example that I'm giving you. So anyway, in our industry, they started with AI and machine learning expert with superficial understanding of engineering. And then after a while, they went to the other side with domain expert with superficial understanding of machine learning. In reality, this is what we need. Petroleum data analytics expert or petroleum data analytics engineers will have completely be domain expertise, and then they have to become expert practitioners of AI and machine learning. And of course, if they want to do research, then they have to become more detailed, fundamental of AI and machine learning. So, and that's the problem. There are a lot of buzzwords. Let me ask you this. You can see, my question to you is, if a company come to you, right, and tell you that they can make a master reservoir engineer in just 1 month, what do you think? Do you believe them? Don't you think when they say that it's all marketing and business, has nothing to do with truth? Of course, keep one thing in mind. This is not real. Nobody says that they can build a master physicist in just 1 month. No company has ever done such a marketing. And I'm just showing to you this to see how unrealistic it is. However, this one is real. There are companies out there, if just go to Google and find it, is that it's a real marketing. They say they can make a master data science in just 1 month. And that's why this is a problem right now that we're dealing with. So what is the difference between machine learning and traditional statistics? That is one of the things that I'm talking about here, right? Statistical analysis, folks, uses existing model. When you get linear regression, you already made a definition, decided that it's linear, right? It's a regression and it's linear. When you say nonlinear regression, you also made you have to identify, is it logarithmic, what kind of equation it is, second, third, fourth, fifth order. And so it is an existing model that you start with, and you identify a pattern in the data. You find out which one is going to match. So you match, if you use a statistic, you match predetermined pattern to the data, and you do it deductively, following an Aristotelian approach of the truth philosophy. So traditional statistics is all about correlation. How about AI and machine learning? It discovers existing pattern in the data to build a model. It doesn't start with a predetermined pattern and to see to which one of these patterns, I come with hundreds of them, to which one of these the data matches, right? Decline curve analysis is something you all know what I'm talking about. And it discovers pattern in the data inductively, not deductively. I'm going to explain it in a second. Following the Platonic approach to the truth. That's a difference between Aristotle and Plato. Plato was Aristotle's teacher, by the way. And AI provides correlation, same as statistics, but also it provides causation. That's what explainable AI is, which unfortunately there's not enough time for me to explain it, but if there is any question, I can answer it. Let me talk about deductive versus inductive reasoning. So deductive reasoning starts with a theory, and then it confirms a series of hypotheses, and then it arrives at a conclusion. However, inductive reasoning is different. Inductive reasoning starts with the data that you have, then it infers conclusion from the data that it has only, and then it arrives at another conclusion, or it's conjecture. Conjecture is conclusion formed on the basis of incomplete information, because when we get data from a specific situation to build a model, what do we know? We know that we do not have all the complete data that could be generated by that technology that we're trying to model it. So deductive reasoning starts with a general principle, and it goes to calculate or identify a special cases. However, in the other way around, inductive reasoning starts with a special case, and then it tries to identify the general principle. That's the main difference between these two approaches. In general, so when you're solving a problem, whatever that problem is, let's say we're talking about reservoir, a given mature field. Let's say you even have 100 wells and 20 years of production. Does that mean you have every single piece of information from that field, that reservoir? No, because you could have, instead of 100, you could have 500, and instead of 10 years, you could have 50 years of production. So you don't have everything, but that process, that unknown function representing the reality that you're trying to model has incredible amount of data that you don't have, but you have some of it. That data that you have, you use it to train. If you're using statistics, you do it through set of hypotheses, and then you come up with one of the equation that identify which one of these hypotheses that you used is correct. However, in machine learning, it's a learning algorithm that you use that data to train, and you come up with a final representative model that it never ever is one equation. Rather than, if you want to put it in equation, it ends up being hundreds and thousands of equations put together to explain that. So the difference is statistics fitting data to predetermined equation, and machine learning discovering complex pattern in the data. And if you look at this, you can see that while traditional statistical algorithms are not part of the machine learning, many of these traditional statistical algorithms can contribute to certain machine learning technologies. It's a fact. So I'm not saying you shouldn't learn statistics. You must. Here, the traditional statistics are logistic regression, linear regression, multivariate regression, Bayesian network, Markov chain, support vector machine, k-mean clustering. You should know that, but these are not AI and machine learning. What AI and machine learning is, that to a certain extent may even uses this traditional statistic, is neural network, fuzzy set theory, evolutionary computing, LSTM neural network. You have to use them, recurrent neural network, but you should not use them in the same way that you process the natural language. But anyways, with that said, I came to 4:30. It said, let's see, I'm going to take another 2 minutes, talk about engineering application of AI. So folks, there's a difference between engineering and non-engineering application, right? Solving engineering problem requires general intelligence. Don't get me wrong, I'm not saying general intelligence is simple, but it doesn't require domain expertise. And non-engineering application does not require domain expertise. However, engineering problems require domain expertise. That's why as engineers, you guys have to go get bachelor's, master's, and PhD degrees to be able to work in chemical, mechanical, petroleum, any engineering, right? So in 2005, where Google generated the image recognition, right? So it shows you all of these pictures and it says, okay, which one is cats? Which one are dogs? And the algorithm, the convolutional neural network can separate them beautifully. Is this simple? No, it's very, very, very hard. However, folks, I have a question. Do you need a bachelor's degree to identify cat and dog? Or a PhD? No, a 5-year-old can do that. So it is about general intelligence of the human being. It's not easy, it's not simple to do it, but it's general. So face recognition, a 5-year-old can tell which one is mom, which one is dad. Object recognition, which can tell the difference between a car versus a bike versus a pedestrian, right? You don't need a degree to do that. How about voice recognition? You use your cell phone and you say Siri and you ask a question and Siri answers, right? So that's very, very complex. Don't get me wrong, but you do not need a degree in engineering or in anything to be able to recognize voice. Kids can tell mom talking or dad is talking. An autonomous vehicle, even right now, guys, do you need a bachelor's degree to be able to drive a car or drive a truck? No, you don't. There are people who are fantastic drivers, but they can't even read, correct? So again, this is not an engineering approach. Translation, a kid can speak multiple languages, and caption generation, that LSTM that they came up with. So, however, let me ask you this. If I have a 5-year-old that I just said, general intelligence, I say, do you see black dots and yellow dots? Yeah. Can you draw a line that separates these two? Yeah. Here it is. Very good. You don't need a degree to do that. However, you don't know this, but I'm going to tell you that this is nonlinear, my dear 5-year-old. Can you do a linear, straight line with this? Can he do it? Can she do it? No. They need to know mathematics. If you ask for linear separation, then if they can use the mathematics, they can do that. So that's what I mean. It depends what kind of problem you're solving, whether you need a certain domain expertise or not. And in order to teach the machine learning, you need that domain expertise. How does human brain solve problem? Does human build equation and then solve them to find a solution? No. Our neurons in our brain includes dendrite, cell, and axon. And it does it through observation, experience, and trail. So I think I'm going to stop here and go to that geoanalytics. Otherwise, it's going to be a waste of your time. So I'm going to just only take 10 minutes to show you what geoanalytics is. So here's geoanalytics. Now I said all these things about AI and machine learning. I'll give you an example. That recently is AI-based geological modeling. So traditional numerical reservoir simulation, right? In traditional numerical simulation, first, the basic or the original geological model is developed by G&G expert. They give it to reservoir engineers, and reservoir engineers have to change it, right? To get a history match. But the key is that development of the basic original geological model that is based on field measurement, well log, core, seismic. It uses assumption and interpretation. And then one thing they do, they use spatial interpolation for the reservoir characteristics between wells using kriging or radial basis function. This spatial interpolation, you know that, right? The reservoir characteristics between wells. So if there is 3 wells, right, it have a porosity of 4, 10, and 16. And if you need somewhere in the middle of them, first you do this, and then you go, oh, between 10 and 4, then here should be 7. Between 16 and 10, it should be 13. And between 16 and 4, it should be 10 here. So that is that spatial interpolation. In spatial interpolation, if you have existing production wells, right, and then you have existing injection wells, then you can actually do that for every single one of them. You draw that, you identify what should be between them, and that's what happens. And then you use that to generate the gamma ray in that case, right? This is the distribution of gamma ray based on this spatial interpolation. This is what's been done. However, in traditional numerical reservoir simulation, the basic original geological model is developed. The traditional numerical reservoir simulation that is developed using geological model never, ever results in a history match. So every time you receive the first original model from GNGs, you use put it in the numerical reservoir simulator in order to do the history match. You never, ever get a history match. You know that, right? To achieve reasonable history match, then what you do, you have to modify this geological model in order for it to history match. And therefore, what it means that in traditional approach, you start with geological model and you come up with a reservoir model. Right? This is the traditional approach. However, the AI-based approach is the other way around. You start with the reservoir model, actually. Then you're going to come with geological model. Let me explain that to you in a second. So AI-based geological model is developed using spatial-temporal interpolation, rather just spatial interpolation. That geological model does that. And this is due to the fact that fluid flow in porous media is based on space and time, not only on space. If you look at the diffusivity equation, we know everything changes as a function of space and time. So if this is the reservoir, in the bottom we have the reservoir. I'm going to show you the difference between AI-based reservoir modeling and traditional numerical reservoir simulation. In traditional numericals, so in the bottom you have here, you see they have the wells and they are completed in the reservoir. This is the reservoir which is in the bottom, and the wells actually are in the top. That's where the oil, gas, water production is, right? Or any pressure injection measurement is done. But it's actually that you history match the oil and gas production, not pressure in here. But anyways, so that's in the bottom, that's in the top. So what do? We model the reservoir characteristics, right? And then we'll give it to the reservoir simulators and in a traditional numerical model, and they match the production by modeling the reservoir, right? And they do it, they go from bottom to up because they're trying to find what happens in the production when they model the bottom. The AI-based reservoir model is exactly the opposite. It starts with actual production, actual oil and gas and water production, actual wellhead pressure, choke setting, flow line pressure. It starts with that, and then it uses the actual historical production, and then it matches the historical production by modeling the reservoir model. That's why it's called top-down modeling rather than bottom-up modeling. That's the reason we call it. So with that, in geoanalytics, dynamic field characteristics, fluid injection and production are used as a tool for distribution of the measured static formation characterization during the geological modeling. In other words, instead of using spatial interpolation, we use the historical production, and we create spatial temporal interpolation and dynamic conduct. And then that allows us to generate what we call dynamic conductivity map in an AI-based approach to recognize the pattern of static formation of characteristics as a function of injection and production. So very quickly, let me show it to you how it works. This is what I'm showing you is an actual offshore field in Southeast Asia. This is an academic thing. And it has this many production wells and 5 injector wells. So the first thing I'm going to look at is, okay, as you inject this in this injection well, right? This injection well is going to impact the production from these producers. Here, and you can see every injection well. So this is all the injection communication with the producers, right? But at the same time, every producer interacts with the producers around it, right? So this producer is interacting with producers around it, and this one, and you can see this communication between all of these wells to one another for every day that they produce, right? With that said, I'm going to put it all together. These are all the communication between the producers. This is all the communication between producers and injectors. Then when you take all of that, then you find out how much conductivity is going. You identify the communication between them. And then this is what you get. This is the dynamic conductivity map for all of that wells. Now watch, if this is gamma ray and this is the conductivity map that through AI we calculated, then a traditional, purely based on space, if it's gamma ray distribution, is like this. But the gamma ray distribution, instead of using traditionally, but using AI through dynamic mapping, the same exact data from same exact number of wells provides this one, not this one. For density, this is the traditional spatial interpolation. This is AI-based, which is a spatial temporal interpolation. Clay volume, resistivity, formation top, formation thickness, porosity, permeability, initial water saturation. So that gives you a completely different model. So since the time is, so let me show you one thing. So when you do that, you can actually watch this. What you're looking at right now, the color of green shows you the distribution of original oil in place. Then for every month that you produce, you know where the oil is coming from. And the distribution of oil in place, you have it here. The same thing is true for, the same thing is true for pressure. Watch. This is exactly, you use this dynamic mapping and see how pressure changes as a function of time. And then that's how you find out where to drill. So I'm going to show you the final results. This is an actual results presented by the manager of the company we did it for. These are the 4 wells. 3 of them was done by numerical simulation. This one done by TDM, the top-down modeling, AI-based. Look at the results. It was done in the results generated in April 2020. This one was developed here, 86 months. This one, 65 months. This one, 62 months. And TDM, 22 months. What you're looking at is the first 6 months of each well producing. This is TDM, my last slide. The same thing for the average of entire production. I'm going to stop. Thank you very much for it. I went 2 minutes more than I was supposed to. Sorry. I'm done. If there is any question, I'll be happy to answer.
Thank you, Doctor, for this insightful presentation. Now we'll begin by addressing some questions from the audience. So the first question is that, what are some examples of the application of artificial neural networks in petroleum engineering?
To be very honest, there is examples everywhere. There's example, at least I can tell you what I have done, what we have done for the past 30 years. We started a lot with hydraulic fracturing optimization. We did it then for drilling. We did it for ESP. We have created a complete top-down modeling, which is it's a complete reservoir simulation. It's not numerical. It's purely based on data. It takes only 10 to 20% of time to develop it, and 10 to 20% of resources for any team to need it. So it literally, anything that you know and you're good at, you can do it through AI, purely based on AI and machine learning.
Thank you. The second question is that, how can a petroleum engineering student or fresh graduate expand their knowledge in AI? So should they take courses or do masters in machine learning?
To be honest with you, both of them. It's to be very honest, it's very, very tough to do that in undergraduate. In undergraduate, we teach one course, and the idea is to get an enthusiast. So when you get exposed to it, I like it, I'm going to learn it, and hopefully in your master's degree, you work in that area. You can Google my name and send me an email, shahab.mohaghegh at mail.wvu.edu. What I can send to you is what I put together is called AI Primer for PDA, which literally gives you hundreds of links of videos, lectures, books, papers that you have access to it on the and you can go to it. But keep one thing in mind: if you are an expert in reservoir engineer, how long did it take for you to become an expert? Believe me, it's going to take you the same amount for AI. So be exposed to it, be enthusiastic, come and do it, but do not think that you're going to learn it in a very, very quick time and amount. It's going to take time. It's going to take a lot of effort, but definitely as a petroleum engineer in the context of PDA, you're 10%, 100% more possible for you to become than somebody who's doesn't have this degree.
Thank you. Our third question is that would case-based reasoning be considered AI?
No, actually it is not. That's something I went through about 12 years ago when case-based reasoning came in. It is interesting, but one of the key things that case-based reasoning is very, very hard for it to do is prediction. It is good for looking at the data. There are a few books generated. It's really nobody think about it as that's another thing with AI and statistics. For example, random forest. Is random forest AI based? No, it is not. It's a statistics, right? But can you solve with statistics? Yeah. So my point is, go ahead, anything you come up with that makes you interested, go and learn from it and see if it's true or not. But this one is not an AI machine learning, but you still need to learn more about it.
Thank you. And our final question is that what do you think are the major challenges that prevent the intensive application of AI in the oil and gas industry?
As I said, one of the major problems that we have had is the management makes, that's why, by the way, let me tell you, a lot of people don't like me. I'm sorry. It's because I'm very, very poor when it comes to politics. I can't. If something is true, I tell you. You don't like me? Sorry about that. I don't mean anything negative. But that's one of the problems with the management in our industry. Many people in the management, they don't know anything about AI, and they use people. I can't tell you the name of the company. I mean, if we are in person, we can go have a coffee and I tell you which company is that. There are several. There's another one that actually there's a link I can show you. It's on the internet. I'm going to tell you both of them. In the first one, that was a long time ago. It was in about 2007, 2008. This company that you all know exactly who it is. It's a very, very famous company in the United States. They paid incredible amount of money to a group from Google. And don't forget, you know where Google is, right? It's in California, Northern California. And this company also at the time, their headquarters was there. Anyways, so you know exactly who I'm talking about. They did that. And you know what? After years and tens of millions of dollars and all the data, you know what they told them? They come to the conclusion from AI and data analytics, and they told them, we found the solution. If you need more oil, you need to go places that have higher porosity. That's what they came up with. And another company like that was hired in North Dakota for shale Bakken. You know what they tell them after getting incredible amount of money and time that they have no idea what engineering was? They said, oh, you want more production in Dakota? You have to do it when the temperature is very good. It all has to do with the temperature. Now the temperature, 10,000 feet under the ground, the temperature in there. So what does that tell you? That tell you they have absolutely no idea what this technology is. So yes, if you want to be an expert in this area, you have to be domain expert. There is no doubt about it.
Thank you, Doctor. Some students are asking if you can type your email in the chat box.
Yes, I'm gonna do that. Okay, I'm sending it to everyone. I just send it to everyone.
So by this, I want to thank you, Doctor, for the time you took to share your thoughts and experience about machine learning and AI in the petroleum industry. And thank you to everyone who participated and attended our first virtual conference. And a special thank you to our moderators, presenters, and guest speakers, and to our conference co-chairs, Dr. Muhammad Solomon, University of Houston, and Dr. Ben Abenhak, Marietta College, who made this year's pioneering event a successful one. So this concludes our session today, and don't forget to join our closing session and awards announcement.
Dr. Mohaghegh, thank you so much. It was a great presentation.
Thank you. Thank you so much.
Indeed it was. Thank you very much.
Pleasure. Thank you.